Okay, I'm John Schaap. I work for the Dutch PDOK. And PDOK, that's an organization in the Netherlands who disseminates information. We have a booth downstairs. Perhaps, perhaps some people are already seen us. We are near the entrance. In this presentation, I want to give an overview of what is actually can be done with vector tiles, because vector tiles is nowadays not part of the Inspire standard. But I think that's some kind of missing. And before I want to go into details, I want to ask to the people who has ever heard of done something with vector tiles. Okay. And then who has used vector tiles in the daily life? Okay. Who is using Google Maps on the mobile phone? Okay. And who is using data from the harmonized data on the mobile phone from Inspire? Okay. In the Netherlands, we have all our data sets and from the municipalities, and they come to we disseminate them for the Dutch key registers, and the PDOK, that's a Dutch abbreviation for public open data on the map, and it's like serving the data. Free of charge, we deliver all the Inspire data to open to the public. And all other data sets in Holland from public bodies we're serving as a kind of integrator or disseminator of data. Now we're also working with link data, and we have also like maps and photos, elevation data, and we're also working now on 3D sensor data. But these are not topics of this discussion today, but if you want to have more information about that, then you have to go to the booth downstairs. What's in this presentation, I want to have it about the key registers from topography, and then we have one for large-scale topography and for small-scale topography. It's the main data sets are from the top 10 NL. That's based on aerial photos. The scale is actually 1 to 10,000. And the other topographical set comes from measurements in the field. It's from the municipalities, the maintenance, construction of motorways and water railway organizations. And that's more detailed. Is the 1 to 5,000 or the till 1,500. And these two key registers are actually integrated with the whole system in Holland with other key registers from the cadastral data and the building addresses administration. But what's actually now the point is that we want to we supply this data, and we want to see it at all the scale levels, because somebody using the data is not interested in a certain scale level, but you just want to zoom, and that's why I put the zoom levels as numbers behind the various data sets, because an user just sees it as one data set and one experience. And with the sets we have now, the standard sets, we are having actually some challenges to show them as on our sites. What's actually the problem is, because the data is heavy used, we have a lot of different use cases for this data. And that means that we have all kinds of visualizations. And that's good, because every customer has his own want to have his own visualization. It's used as background. It's used for underground or a base layer for other purposes. But these kind of use cases are growing, and also the need for more visualizations. And what's now actually the problem is the popular the data set is, and the more it's used, the more the higher demand is for all kinds of different visualizations. And we are serving that now, and we have an infrastructure doing that. But it is actually quite a huge load on all our resources, because every data set, these scale levels, are styled at server side, and then they rendered, and they must be cached because we have a very high availability and lots of requests, because there are some, all the municipalities are using our data sources. And the problem with the WMS and the WMTS is that we have to cache these data sets, and we have to cache them for all the zoom levels. And the more use is of these data sets, then means also that the higher the demand is on the servers. Now, a solution could be actually to do this with client-side client styling, and that's what you do in vector tiles, and therefore we have a demo. And the biggest advantage is that the data in the vector is encoded over the communication line, and that means that there is a lot of reduction in data transfer load. And that's actually what's needed. Now, and also for the various use cases, development is much more in line with a normal website development. And also, there's possible to do interaction with the map, and to because you're showing vectors, you can have to see the objects from various viewpoints. Things with the current Inspire service is never possible. Now, that's where we made a demo to show the possibilities, and I only will show it very short because we only have 10 minutes here. But these links are in the presentation and also on in the app from the Congress. Oh. Now, the big difference with vector tiling is actually the site is in Dutch, but there are some keys, so I think everybody can use it. And if people have problems, then we can show it in our booth to explain more about it. What actually is, you can have client-side. Is it shown actually? Strange. I see something here on my. It's not.
To stop the presentation, and then it shares the other
Okay.
screen as well. A couple of other speakers in front of you.
Okay, that's better. This is actually the vector-tiled map of the data sets. What you can see here is that you can see client styling. It means that you just can very quickly change different style sites for different purposes. And this will actually help us in the problem that for every use case, various visualizations are needed, because we only have to serve one set, one vector tile, and all the styling is done at client side. So that's actually the biggest advantage of client style mapping or styling. If we have certain use cases, for example, public transport, then we actually can just take in this case, the trains, and just highlight them in a certain color. I think it is showable. Train. So you can make for very quick maps for a certain use case. In this case, if you want to focus on public transport and the trains in special. Also, like labeling, it's just like one click, like client styling. You can actually do the annotations on the map. In the presentation, I talked about the zoom levels. These are actually the zoom levels and with the related products. And if you just go from the highest zoom level, you can just go down to the various products and end up on the street level detail from the and here you get one user experience for all the zoom levels, and something was not easy to do or undoable with the Inspire services. Another big advantage is that we are actually having vectors, so that you can actually see things from a different side, get bird view, and rotate. Also, what's not possible with the standard sites. Get it clear. What actually another advantage is from a quick one is that you actually can encode and you have the real vectors. What happened is if you select an object and it's actually already then you can see in the right pane that's actually the number from the key register of the object, and it makes it possible to make a whole use case and use these objects in other, for example, linked data examples or use cases, whatever. What can we do? In this demo it's on the web. We have put it on GitHub, so the code is clear and everybody can look in it and see if it's usable. I think the Inspire standards must be used with this kind of technology, because if we don't do that, then we never get our usage of the linked data of the data from Inspire, and then we only have lots of harmonization and data sets, but we never get good use cases of using this European data. That's actually why I think we must adapt this standard. That's the presentation. Yeah.
Jeff Cronin from Luxembourg. That is a really nice demo. Could you please just quickly tell us what software is used on server and client side?
What actually is this is like we are serving here vector tiles, and that's on the server side is just vectors, and because the vector tile is standard, similar as VMTS and VFS, you can use things like or in a leaflet or open layers, all kind of different technology to actually to use it in your website. So it's not we used here for a certain demo, and you can see all the details about on the GitHub about what we have used. But actually, what you must do, you must serve the main purpose is that you serve actually the vector tiles, and then you must let the implementation to the website users or the website's developers, and you must just not limit to certain technologies.
No, that's sure. I was just wondering what was used there. I know the concept, but the software that was used to generate the vector tiles was more.
It's here we said it's the demonstration. We have made for the toolset we have made Topography. We have made the tiles, and this is the specification we're using, the map box, okay. And all the details are actually, and also how we used it and how we use it and how we did it is described here. So it's perhaps not for the audience to actually explain this all. Yeah.
Okay.
Yeah, quite interesting presentation, thank you. I'm actually Joan Masó, the main editor of the WMTS standard, so guilty as charged. I can definitely recognize the value of vector tiles, and what we are doing in OGC now is try to make the tiling model independent from the service itself, in order to other services are able to reuse the tiling model, including vector tiles. But this is not my presentation today. My I work at the CREAF there in Barcelona. I wanted to remind you that. And my presentation is about another standard candidate. It's not a standard yet. It's just something that has been discussed as part of the work of the subgroup in OGC that is working with W3C. So it's still a working item, but it's something that is working. So I wanted to present it to you if that could be useful here in Inspire. So this is the current status in Inspire. I was just yesterday using the actual portal and visiting one data set, whatever, and there is a service link there, and you click it, and you see it in this browser. Well, we know that the reality these days is that the WWW, the web, has also understood the necessity for web services. Well, maybe, I don't know, 15 years ago, the OGC was pioneer in at least geospatial services, but now the web in general is leading the process. So in practice, what is happening is that the OGC is doing things one way, and W3C is kind of specifying things in another way that is, if you want, more RESTful, more close to how HTML works. So we have to avoid to have these two different things and try to work together. So I have no idea what happened here. The idea is that we want to offer something it's kind of funny, to offer something in the same way that the web is for everyone. So if the web is for everyone, can be maps for everyone. So these kind of guys here that looks like developers to me, yeah, could we transform them and making younger? So can we do it so easy that it is possible for children to do that? To publish maps in the web? Well, that's the question. So the aim is precisely that. Web mapping today is kind of complicated and requires somewhat specialized skills. We all know that. You need to be a little bit of a developer. You need to know how to program. You need to know some geospatial concepts here and there. That's true, and maps for maps for HTML and MapML have this objective of making maps closer to the browser by extending the HTML into declarative maps. So in practice, to embed a map into HTML, you will only need to know HTML itself. So we want to lower the barrier and make it that everybody that wants to make a map has the tools to do so, so in the kids level, but also we want to do it in a way that it scales up, so professionals are also part of this, and we are now breaking that wall, like in Germany, you remember, and now creating an harmonic future for everybody. So technically, what I see here is 4 levels of complexities. The first level of complexity is the traditional WMTS, WFS, WCS way. We define on top of the web another protocol level that is the OGC services. You have to know how to create those URLs. You have to know how to make a guest or a post, and then you receive something back, and you need to be an expert on how to decode that. Then we have the second level, this next generation of OGC services that are under discussion, but I believe they are progressing fast based on this new Open API Swagger thingy that instead of defining a protocol on top of HTTP, it uses HTTP directly to serve resources on the web. Then we have the third level, that's the JavaScript API that is able to embed maps on the web, and those APIs were just mentioned. Leaf is one of them. Open layers could be another, whatever. But finally, we are thinking about this HTML extension to declare maps resources on a document in the same way that you would add an image, PNG, for instance, in a web page. So in the first case, you need to manually build a JavaScript code that builds the request, that manually interprets the response, that extracts and shows the information. If we go to the next generation, this Swagger possibility, then automatically the code is created from the OpenAPI document in principle, and you no longer have XML documents, you have JSON that it's automatically parsed, at least by JavaScript. You still have to extract and show your information yourself. If you go to the next level, the JavaScript API, so it's simplified. You need to create a division in your HTML page, and you have a couple of lines there extracted from an example of a tutorial. This is going to work immediately, so the map is there. But still, you need to know JavaScript. So what about this other thing? So in HTML, there was already a map entry, but it was not for that. It was for defining in an image regions that are active. I don't know if you remember the thing from the past. It's not very used these days, but it was. So the idea is just to extend that, providing latitudes and longitudes of the center of the map, providing controls, and providing the possibility to add a layer directly. And here we are using the OpenStreetMap example just to include one reference to that, and that's it. You automatically have this visualization in place. You don't need to know JavaScript, you don't need to know leaflet or whatever. The technology is, in principle, embedded in the browser directly. But this is the proposal we need to convince, of course, the browser implementers, so the Edge, the Chrome, the Firefox guys, that this is a good thing, and before we need to convince the W3C to make that a standard. So, do you remember that I had a link here, and I had a link source with this thing here? I need a pen. Okay, this stuff here. So what is this? This is not a normal file. This is a MapML file. So a MapML file is a thing like this. It looks like HTML, but it's not. So it starts by MapML, it has a header, it has a body, and then it has an extend. And in this 10, it defines some variables that are a bounding box, Z, whatever. And then it has a URL template here that actually communicates, in this case, in particular, to a WMS, but it can do tiles or it can do features. I don't have time to go into the details, because actually the whole idea is to hide the details. So you simply have these files in a list of files in the internet, you produce that as Inspire, and then people can just link them in their pages, and they automatically become living maps. So that's the whole idea. You can see it running in Natural Resource Canada. Actually, this is the work of Peter Rutherford in Canada. This is that's pushing that. I'm just helping as an interface in the OGC, and we are doing a test bed on this with other institutions now. So this is an example. I'm just picking one example, and I'm just showing the fragment of code that allows you to show that map of bubbles, in particular of clean energy sources. So there is already a community form, a W3C community that is also synchronized with the OGC. That's the page of the community you can join, and eventually we can make this also of interest of the Inspire community. And the whole idea is, let me repeat that everybody are able to publish Inspire datasets in their posts using this approach. Thank you.
In Great Britain, I've been watching the spatial data on the web interest group But I think I've understood, suddenly clicked for me with the presentation. That's the benefit of actually coming. So just to check that it has, I think what you're saying is that as a publisher, I would still have my WMS or WMTS or something, and then I'd also create a MapML file which would encapsulate all that complexity so that somebody with a properly equipped browser just uses this new HTML element to reference my MapML file. Is that right? Have I understood?
You got it exactly right.
Good, thank you.
When this is going to be available, well, we don't know. This is the route that we have to walk with all the actors.
Okay, thank you.
Yeah, good afternoon. I'm happy to be here. My name is Ralf Hackmann from the company Conterra. We are based in the northern part of Germany, in Münster. We're doing projects in terms of Inspire and open data for about 20 years now, from a local to European level, and also in lots of other sectors like forestry, insurance, industry, and so on. And I want to talk to you today about natural language understanding in web mapping application. So what does it mean? It's really just, I must find the keys here, that you can talk to your application, say to her, hello, show me your maps, show me your data, etc. Okay, and the key challenge is just to generate map interaction from the spoken word. And this is where natural language understanding comes into place. So you have to transform the natural language, the spoken word, into a form that a web application can process. And then we can perform interaction with or even without the map. So on the context, you all might know today everyone is using systems like Siri, Google Assistant, Cortana, Alexa, and so on. And it's all about this topic of artificial intelligence, and there the machine learning, and a part of the machine learning is the deep learning, which uses neural networks to teach the application, to teach the software itself. So, and some people say by 2020, half of all the search inputs are done by voice and not by typing in something like nowadays, more or less. So, and we find that this language interface also fits in very well in WebGIS applications and Inspire applications. So I will show you how it works in four basic steps. First of all, we use the browser's web speech API for the speech recognition. This is that the spoken word is transcribed into text, and someone says zoom to Antwerp to the application, and then we have the transcription zoom to Antwerp as a text input. For the second step, there we use open source software framework, the RASA controller, and this framework does two things. First, it recognizes the intention of the user. So this is zoom to somewhere, zoom to a location, for example. And in the second step, it extracts the entities the user is interested in. So this is, in this case, a specific location, like a city, like the city of Antwerp. Okay, and after this is done, the a processor chain is called, or there are more so-called processors, which are a predefined sequence of steps to do the interaction coming from the commands from the RASA controller. And here, for example, this is a view processor, which is to be zoomed to a specific place, zoom in, zoom out. There's lots of more. I come to that in a minute. And the last step always is the voice output to inform the user what happened in the application, what the application did or maybe not did or not understood. So there we use as well the speech, web speech API. So the most work has to be done here, the second step, to train this RASA controller with all the commands. And these processors I was talking about, we had to implement in our software. We use our MapApps software web mapping application. And there we created a first set of different processors like this view processor or like a weather processor which uses the web speech, the open weather map API, or near me processor which searches for features close to the user, etc. So this all has to be implemented in the software, and it is not too much effort with our MapApps software because MapApps is built on so-called bundles, which are the small building blocks like Lego building blocks, you know. And so we could step by step create more and more bundles regarding these processors I was talking about to integrate it in the software, and so the software can grow by working with this natural language. And there are, of course, some challenges. One is, of course, that different users use different wording. So GIS expert might say, switch to aerial view, and GIS newbie says, show me satellite images, or enable the protected sites layer, and another one says, show me all protected sites. So they all mean the same in the end, but the wording is different, and the RASA controller and the software has to decide, okay, what does he mean, what is his intention, and what are the entities he's interested in. So we had really to train the RASA controller with lots of samples coming from different surveys, from surveys, and to teach to learn the RASA controller, and after that it takes over that the deep learning mechanism start to bring the software to learn itself. Okay, and of course, what does this all have to do with Inspire, you might ask? It's clear. The conversation with smart machines will become more and more the part of our interaction when we interact with technology in the future. Smart maps, smart apps, all that stuff, and so why not also use in WebGIS and, for example, in Inspire applications? As you all know, and we heard it before, we have to bring Inspire more into use, the rich data we have, and it might be a good idea to use these modern approaches to make it really easy to get the Inspire information in an application to the end user by letting him talk to the application. So now I wanted to show it live, but I decided to make a small movie because of the voice input here with a microphone, and I didn't know if it worked, so I created a demo movie. Of course, you can come to our booth down there at G3 and talk to MapApps. There we can try it live if you want. And now I will show you a small movie. I hope this works here. So I don't get this. Okay. Oh yeah. Let's talk to MapApps. Hello, MapApps. How are you?
Hello.
Oh, that was short. Hello, MapApps. Can you help me?
You can say, hide all primary schools or remove all high schools.
Okay. Hello, MapApps. Zoom to Amsterdam.
Okay, I will zoom to Amsterdam.
Pretty nice. Hello, MapApps. Hello, MapApps. Can you show me the aerial view?
Okay, I will switch the base map to aerial view.
Hello, MapApps. Show me the map content.
Okay, I will activate the map content.
Oh, I see there is a layer of bathing sites. Hello, MapApps. Activate bathing sites.
Okay, I will enable bathing sites.
Hello, MapApps. Hello, MapApps. Thank you.
I'd be glad to.
Hello, MapML. Where am I?
You're in Antwerpen. Okay, I'm looking for your current location.
Oh, great. Hello, MapML. Zoom out.
Okay, I will zoom out.
That's not enough, so I ask her. Hello, MapML. Set scale to 1 to 200,000.
Okay, I will set the scale to 1 to 200,000.
Hello, MapML. And how is the weather here in Antwerpen?
The temperature in Antwerp is 18.49 degrees Celsius and the weather description is clear sky.
Okay. Hello, MapML. Which bathing sites are within 200 kilometers? Okay, try it once more. Hello, MapML. Which bathing sites are within 200 kilometers?
I have found 908 bathing sites at a distance of 200 kilometers.
Oh. Hello, MapML. Thank you.
No problem.
Hello, MapML. Can you switch to 3D view?
Okay, I will switch to the 3D view.
That's pretty cool. Hello, MapML. Zoom out.
Okay, I will zoom out.
That's nice. Okay, that was really impressive, MapML. And in the end, maybe she can tell me a joke. Hello, MapML. Be funny.
How can you make number 7 to an even number? Just take the S out from it.
Okay. Hello, MapML. Thank you.
I'd be glad to.
That are random jokes, so I didn't know what come. Okay, thank you. Which standard?
I mean, you present an architect, well, a simplified architecture of your system. You have a voice listener, let's call it that way, voice recognition, then you translate those phrases into actions, and so on. So have you thought where the Inspire standards or the Inspire specifications that we have here, normative, come into play in your system?
At least when you use the services which are set it up upon the data. So we consume the Inspire data. I mean, the data is there, the services are there, and that was just to show a different way to consume these services.
Yeah. Okay.
And if you use WMS or an ArcGIS server, feature service, it doesn't matter.
Yeah, when you asked for a joke, I was expecting that you will ask for the metadata.
That would be a good joke. We have to create a metadata processor, and that is really difficult, I think.
I think it's a partial answer to the last question. Another part that the standards will play a role is in training the speech recognition to recognize the terms that are in the code lists. So the code lists become training for the speech recognition to make it much easier not to have errors. So the code lists are fundamental to interfacing with these kind of AI applications in the end.
Yeah, that's the most difficult part, the training of the RASA controller with the right commands, or with commands he can translate into commands. Yeah. And there are lots of work has to be done still, of course. The same is with the processors. It's just a set of processors. We don't have yet a processor which can execute, give me the attribute info of this feature, or so-called, etc. But we can do this, but we are not there yet. It's just the first prototype. The main thing was to do a little research on this RASA controller and how we can use this with the concept of the bundles to create new processors which can be easily integrated in the software. Yeah.
Can you hear me? Yeah. I am Henrik Ulriksen Schiller. I'm from the Norwegian Mapping Authority, and today I'm going to talk about a little part of our geoportal, which is geonorge.no. And we are going to be focusing on digital cartography and symbols. But first, I want to show how we used to do cartography in Norway. We had this old register, and here's an example of an area resource map. And we had the data providers deliver PDFs containing, well, the presentation rules. And on the right side, you can see an example. And this area map, I have like a couple of, or more than a couple, a few ways of being visualized. And further down in the PDF, you would find queries that you had to make. And obviously, this isn't very user-friendly, and we realized that we had to make something better, because this was way too time-consuming and, to be frank, very boring. And that's why we made something called the digital cartography register instead. And on the left side, you can see the PDF from earlier, and on the right is the new register with the SLDs in. And as you can see, we have the different ways of representing the data on both sides. We have one SLD for each way of representing this data set. And you can see that it says compatibility, WMS, and QGIS. And when it says QGIS here, that means that you can download the GML file, the standardized GML file from our portal, and apply this style directly to the standardized data set. And you can see who's the owner and if it's an official SLD or not. So we also have support for crowdsourcing, but not many use them. And it is also possible to deliver like SRE files or QML files, but we only, the requirement to the data providers is SLD as the base format. And if you click on one of them, for example, the one called area type, you will get a quick look on the metadata for this SLD, which is very little at the moment, but we're going to expand it. But you can, for example, see the dataset connection, because this is directly connected to the metadata record for this dataset. So you can get like a cross connection there. And you also see that we have a historical tab for older versions of the SLD, and also a proposal tab. And if you click display file, you will open the XML document, and yeah, that's not that exciting. But down here we have the legend, and this is automatically parsed from the SLD file. So you don't have to like pick a color and say this is, for example, this is it's in Norwegian, but it is like farmlands. And you can also mouse over and get the query that is made in the SLD with the color code and stuff. And on the right side, I have downloaded the file from our portal and opened it in QGIS. And for the regular user, this doesn't say them very much. And as you can see from the query, it says area type equals 21 is farmlands, and that for most people that doesn't make sense at all. And then we of course can download the SLD file and apply it directly in QGIS in this example. And we get a way more visually pleasing map, and we can see where the urban areas in Oslo are and where the oceans are and forests, etc. And this is of course a way more user-friendly approach than having PDFs. And then we have the symbology register, which contains libraries or packages of different symbols. So the data providers can create their own libraries or packages and upload different symbols. So we want them to upload SVG files, which is vector files, and then we can generate raster files for them. And as you can see from this picture to the right, that is the symbol for nudist beach, which you can see from the amazing boobies. And then you can also see that we support uploading multiple variations of one symbol. So we have like a positive, a negative, and one without border here. And what you can, of course, download all of the symbols. You can download one variation or an entire package if you want to. Or you can use them with, in correlation with the SLD files. So here we have an example. We have a library from the Norwegian Directorate of Fisheries, and they have a very small package of symbols on Norge. And they use most of them in the SLD you can see on the right side, which is aquaculture. And it also says here in Norwegian that this only works on the GML file from our portal in QGIS version 3.2 and further. Because we use something called external graphics, which didn't used to work in QGIS earlier. And that means that instead of downloading all the symbols, we link directly to the SVG files. And you can then, I think this one is for the redfish over here. And that means that you can download this SLD and apply it in QGIS. And you don't have to download all of these fancy symbols, but you get the data set represented the way it's supposed to. And this also means that we can build a library for different type of polygon fills, like hatching. And you can use the same SLD for WMS and GML files, as long as the data structure is the same. And then I only have like a last slide. I went way faster than I was supposed to. This is the links to the register now, the cartography one, digital and symbol register. And this is all open source, so you can just go ahead and download it and, well, use it yourself. And there's also APIs over all of these registers that you can use. So you can, for example, look up our metadata records and find a connection to the SLD files for that data set. And it looks like I have a lot of time for questions. We have one over there.
Thanks, it was beautiful. Who was the system integrator doing the ArcGIS feature server thing connected to the PostGIS and the QGIS? So the company, or you did it yourself?
We did it ourselves.
Cool.
In the mapping authority.
Great.
I think so. We have another question.
Thanks a lot. I have a question. Do you have also the Inspire styles available? Because we are using the Inspire styles for visualizing the data, and we have seen that the SLDs provided by the technical guidance documents often don't work out of the box because of some minor XML issues in there. And so we also started to set up a kind of register, a repository with styles. We would be interested into sharing this, or maybe if you have Inspire styles available, would be interesting for the Inspire community to share also this month.
At the moment, we have focused on the national data sets, but of course we want Inspire in here too, but we don't have it at the moment. And we're also currently working on translating these registers over to English so that everyone can use them more easily. Because now they're like half Norwegian, half English. So. But it will be fully English support there soon. But if you have the SLDs that's working, it would be nice to just send them to us and we can put them out there.
Okay. Yeah, thanks a lot.
Okay, on these questions, I think I want to remark that if you look into the multi-cluster, someone have also already posted some SLDs, or in the way, if you have a SLD for Inspire, please go to the thematic cluster and push on as example, because we share in the community anyway. It's common for all. We have time, I think, so for another question, if you have, Maso.
The SLD group in the OGC. Yeah. Okay. The SLD group in the OGC was kind of dormant, but recently there is some activation of it. So my question is there any limitation on SLD that you find especially painful that we should address urgently?
Well, the first thing that we noticed was that the SLD standard just specifies like standard symbols like circle and triangle, but when it comes to polygon fills, it doesn't specify anything. And we see that GeoServer and QGIS have their own way of, well, defining like hatching and stuff. And that is why we use the symbols on the web instead, so that we can bypass those issues. But the main issue was how to define fills.
So, my name is Enrique Soriano. I'm here to talk about a product which is GGIS Cloud that we have developed to try to spread the spatial info and make things much more easy for all of you, for all the community. I've been very glad listening to the previous presentation because I think that we are all very aligned, as we all truly believe that there is a barrier in the publication of the data, and the Inspire data is not reaching the public as it should. So there have been presented several approaches in the conference also, with for example the previous presentation from Joan. And here is our approach from our experience. We are a company based in Spain and working worldwide for Latin America and Europe, and we have GIS information in our DNA. We truly believe also in the official data, in the data that the governments and the spatial agencies produce. And what we are trying to reduce here is the wall between those official data and the publication. So we have created a tool trying to abstract or make the people forget about all the technical details, integrating all the usual components. All of them are open source. I mean, I can say OpenLayers, your network, your server, PostgreSQL, and some other products that we are also using, all of them open source. But you won't see in the presentation or in the demo any trace of it, because we abstract the user from that complexity. Then we have also tried to make it usable for everyone here, not for child, but not also for developers, a medium point there. So we have tried to reduce the learning curve to 0. And finally, Inspire Camps. We have tried to preserve all the Inspire information, and in 3 clicks, you will be able to publish a layer Inspire compliant, not only in the data model if you have taken care of it, but also publishing WMS, downloading services, WFS, and also the famous metadata. As we have said, we are combining technologies, trying to make it so easy, so vulgar that you can create the information from your current data. And in addition to the mandatory services, we also provide with web processing services and embeddable map viewers. Also, you can publish the data in RDF if you have properly defined the concept and the ontologies. And as we are using HTML5 and JavaScript, we can produce a mobile application to be run on Android. So we also offer more tools as the high resolution printing services. We will see, I'm just going quickly because we will try to go to a demo live. And the search engine, everything you upload there will be indexed in a natural language engine using Solar, and mapping tools that are developed as plugins that can be added or removed from the maps you create. Just a quick view to all the integration of technologies. It is based on AP REST with asynchronous download, all the tools that we have explained before, and also providing the capabilities to the organizations to be integrated in their e-government processes. I mean, we, in our experience in the past 25 years, what we have also realized is that, I think all in the room may agree in this, information, spatial information cannot be treated separately as a separate part of a process. It is part of a production process. Many times it is a crucial part on an e-government process, and you need to have it there to make decisions. And once you make that decisions, that information is produced and maintained. So we are offering LDAP connections and also plugins to connect to external applications. Imagine you are in an environmental monitoring facilities workflow, and then in some moment you have to place it or check how many monitoring facilities are in a buffer and that kind of operations. So you can jump to the application and then move back with information to the original application by using plugins. So we are prepared to be connected to corporate GIS systems, searching interfaces, and I have said before, integration with e-government systems. We have also moved on. We have tried to face a problem that we have with the spatial info, and this is when you Google any spatial data that you know that you have published it under WFS, you will never find it. It's very complicated to be found by Google, a data, I'm not meaning the layer. So what we are going now is for the publication of this data via RDF, so external engines can index it. And also it is the possibility to be linked to other systems. So compared to other solutions, what could be our differential values are listed as follows. First of all, we are taking into account Inspire. Nothing that we do with the application is against it. Moreover, it's for it. It's when you have a layer that you want to publish and you do not know what to do, just upload it to the system and you will have the WMS, the WFS. You fill just a few fields of information of that layer, and you will also have the metadata, the RDF services, and the geosearch engines. The architecture has been designed to follow a plugins extension mechanism, so you can develop over it all the tools you need. So I would like to make a live demo just to show you how easy we want to do it. Imagine you are in your organization and you have and you need to publish a map. Okay, this is our interface. We have an administrative part where you can give permission to certain groups, several departments, and they can work independently. They can share the data or not, or keep it private. Then you have the maps part, that is this that you are seeing, and then we have also the data part, which is uploading the data. For example, we will have a map of Brussels. We can show the map. We can, well, you see the map. You see a lot of tools here. You can see the printing service. It goes to an offline request. So then you can define a template for your own organization, and you have it here. You can define the DPI, but these are tools. Okay, you have also the information of the map. You can share it because we want to make it useful for you, the map, and it is like it is useful for you if it is used by people. So you can share it by Twitter, whatever, and you can also integrate it with an iframe wherever you want. I mean, this URL is this other one. You can put it wherever in a web page, as we have done in this very small web page. And you will have it there. Okay, what you have inside is it's a small open layer. Here you have an APK to be downloaded, and then you can edit the map or remove it. But what we have told you before is that we want to make it very easy for you. So we would like to produce, we will try to produce in 3 clicks a map viewer like that, okay? So in the first step, we define which layers we want, okay, as base layers, fine. And then we can upload a layer. I went to the volume points of interest, and then without noticing, you are filling this information, which is then translated into metadata for the data and for the services. You have the categories. You can say, well, okay, environment. These are buildings. This is catalogs. Then you can put tags. Sorry, this is a strange keyboard for me. You are filling this data in such a minute. For example, Antwerp voice, internet. Most of the data that are needed for metadata are default data for your organization, so they are hidden from this interface. So then you save it, you upload your shapefile. It can be done to a database. If you have the data in a database, there is no problem with that. So you have this shapefile uploaded. You have, for example, Antwerp. We are here. It has created now a temporary layer with GeoServer, and then we can play with the styles using SLD and upload it to GeoServer also, saying changing from categories, applying different style. For example, we can go to a heat map, depending on the radius you choose. This is all sample data, but for example, you can go to changing intervals and things like that, and you can do it quite fast. Then, to end the configuration of the map, you can also configure how the information is displayed. You know, the usual suspects: OSM ID, name type. You don't like it. You don't want to show the ID. You don't want to show the name. And you don't want to show typos, so you write a proper label. Okay, and then it is applied directly for the publication. Then you go to the tools, you select all of them, you can remove tools, add tools, as here, and finally you say Antwerp map. Wow. Sorry, the M is not where. Sorry. You again put some labels. This is an Antwerp map. We make it public. We save it. We want to make it public. This. Okay. So we have it here, and we can play as before. You have the symbology standard with the SLD, you have the WMS, the WFS, and all the tools that we have defined, the same zoom level and the layers that we have configured to see the laying and so on. Okay, so we have tried to break that wall and make the publication of data much easier, so they can be found and used by the people. That's it. Thank you.
Thank you, Enrique. We have time for question. 1, 2 questions. Someone? Okay. Thank you, Maso, for active the floor.
Is there any way that when you have these beautiful maps in your screen open and prepared and so on, is there any way to save the map and exchange the map with other map viewers?
With other map view?
Yeah.
With other...
With other tools that show different services together, so integrated viewers, integrated clients.
I'm not sure I understand the...
There is I'm doing the question in a way that I'm easily able to mention that there is an OGC standard relatively new that is called AWS Context. Do exactly that. So
okay,
please
good
take
to
a look.
notice. Good to notice. We can talk later.
Yeah,
Thank you.
absolutely.
Other question? No question? I have one question anyway. Just to understanding, what you offer is something that offer also the cloud service, or is something that could be installed in internal infrastructure?
It's as you prefer. You can be provided with the source code and all the components. Even you can use your own components. You can use your own database. You can use your own metadata catalog. As we are, when we have designed this, we are using standards. So the thing is, whatever you have behind, you can use it. So if you want to use it as a cloud service, it's okay for us. But if you want to have the product installed in your premises, it can also be done.
Okay, thank you.
Okay, good evening all. Still awake and kicking, I hope, for the last session of today. That's okay? Okay. When I started to work in 2007 for Informatie Vlaanderen, our customers could order data on our website. And therefore, they had to register and make their user ID and their password. And after that, they could order the data on our website, and they have to wait until the postman came by with a DVD or a CD with the data on it. So on this medium, they would find data that was 3 months old or even worse. Nowadays, our customers can still access our data. They can access our data via our open and free WebMap tile service, and they don't have to wait until the postman came by or come by, because they can access it immediately with our performance service. And as a cherry on top, they get the data of today that is today in our database. A short notice about a Flemish agency that I work for, Informatie Vlaanderen. There live around 6.4 million people in 308 municipalities in our region of Belgium. And we work with 1,000 public partners and 2,000 private partners. And now I had to cheat a little bit. The mission of our agency is to develop a coherent government-wide information policy and to support and help realize the transition of the government of Flanders into an information-driven administration. So that said, back to our WMTS. So when our WebMap service, unseal new information, like in this example, the 6 new buildings, we retile the corresponding tiles of our WebMap tile service, and we do it on an up-to-date basis. So how does this work? We implemented it with Azure Service Fabric, and the different data processes of the upper left corner send messages of change to a queue, and that queue sends those messages to our implementation, and the outcome is a message with the tile that has to be retiled. So as a particular example, we take this building. So the message of the change of this building, the creation of this building, is a message with the ID and the geometry of this building. It's sent to the queue. The queue sends it to the first Azure API of our Azure Service Fabric implementation. And the result is a tile that has to be retiled, so based on our WebMap service. So I have to explain a little bit how we manage and release our data and how we work with that. We have 3 levels of database per data set. All our CRUD operations are done in the managed database. And when all the operations are done, we make a copy to the staging database in the cloud. And when the time is right, we do make a copy of this staging database to the production database, which is the base for all our applications and services. And we do the latter at night, the switch as we call it, because it doesn't affect our customers then. So let's have a detailed look into the Azure Service Fabric implementation. The message of change is coming to the switch process API, and this API will then check, based on the entity, which layers and zoom levels that are affected by the change of this building. This building is an entity, an object of the entity of the buildings of our large-scale reference database. It's a data set used for large and medium-scale topographic mapping and engineering surveys. Why is that? Our WMTS has 3 different layers of this database. We have a colored version, a gray version, and also a version with only a few entities of this data set. And as you can see, the building that we are talking about is only in the colored version and the gray version, and not in the selection version. So we know only those 2 layers are affected. We also have to check which zoom levels that are affected. As you can see over here, no buildings on the map yet, but from WebMap Mercator tile matrix 12, there are buildings on the tiles. So from level 12 in this case, we have to retile those tiles. The second thing that the switch process has to check is, does the tile has to be deleted or seeded? Now, why is that? Over here you see the seeding logic for a few layers of our WebMap tile service. In the first half, you see the seeding process. So because of our the high requests and users that we have on our WebMap tile service, we decided to tile them in front. So level 0 till 18 for the WebMercator projection and the 0 till 11 for the Belgium Lambert 72 tiles are made in advance, so they can access really fast by our users. We do support the WGS 84 projection, but it's less used than the other 2, so we don't generate tiles in advance. And then the second half of the table is a save item. So the lower levels of the WebMercator and the Belgium Lambert 72 projections, we do a save, but we do not generate them in advance. So the first customer, the first client has to wait a little bit longer than the second one. And that's for all the layers of the WGS 84 projection as well. And the lower levels, we don't even save after that. So you see it over here for our large reference database, but also for an aerial photographic and our historic data sets. So next is a tile aggregation. Every change of an object results in a list of tiles that are affected by this change. So to prevent double work, we aggregate all the tiles that has to be retiled based on the entity, based on the zoom levels, the layers, and the geometries that are affected by this change. And the long list is then made until unique tiles that has to be retiled. So when a switch message come in, when a switch occur at night, this trigger the process of the tile aggregation. So the list of all the tiles is then sent to the queue, and then one by one, those tiles are retiled or deleted, depending on the level of the zoom level of the service and affected tiles. So this automatic process can also be activated directly. This is because when there is an error in our data, or when we have new data for a specific region, for example, for the aerial photos, we can activate this process by defining a bounding box. So this process can be done automatically and also direct. So that's how we make a performant and up-to-date service. But we have still some tasks for the future. We are working on an even faster way of handling the messages of change. So our WebMap tile service is even more and faster up-to-date after a data release. And it would also be great that our business people, so our data managers, can access the direct process and activate it by themselves, where there is still a task for the technical people for the moment. So that said, I would like to invite you tomorrow morning to our booth so we can discuss this topic a little bit further, and also to our meeting day in November in Ghent if you would like to see Ghent after that you saw Antwerp those days. Thank you.
Thank you. We have time for questions.
If I get it right, I have to look at my developer at the front backside row. So the different data processes are initializing this process. So our data managers, they change the data in the managed database. Then they say that the copy can be made to the staging database, and at night it's triggered automatically that the database of the staging database can change to the production database, and then this all is activated automatically. So it's a data manager that says, I'm ready with all the changes.